students, I think we are moving on well. Having distinguished our ductile materials and brittle materials, we want to go ahead and now introduce again other terms, mechanical properties. You cannot understand the mechanical properties if you are an engineer and you are going to the lab. You have to check the strength of the material, check the stiffness, check the brittleness, the ductility, check the stress, the strain, and Young's modulus. So as people who are planning to be engineers, you must be well versed with these terms and how you get it. So you go to a lab and they say, what's the stress of the material? You must know. What's the strain? What's the Young's modulus? These ones are very important when an engineer is choosing a material to use, as we shall see later. So starting with the stress, remember we are going to have our material, for example metal, and we are loading it with weights. Even you see like these bars, they are going to carry the roof of the house and the other floors on top. So we are loading it. So what do we call stress? So stress is the ratio, or we can just say force per cross-sectional area. It sounds so much like pressure, and since it is also force over area, of course the units will be the same like for pressure. So somebody can say stress is equal to force over area. Our units are the same like for pressure, newtons per meter squared, or somebody can even say pascals. Students, remember another unit for pressure is pascals. So they share the units, but the definition may not be exactly the same, though there's a lot of relationship between stress and pressure. The other term, of course, we are talking about a wire, and then, of course, this wire cross-sectional area is a circular one. If you cut it across, it is a circular, so you shall be ending up getting area of a circle. Then, what we call stress, stress. In some books or in science, we also call it tensile stress. So don't get confused when somebody uses that word, tensile stress. So the other one is the strain. The second one is strain or tensile strain, or you can just say strain. This one means is a ratio. This is the ratio of extension to original length. Please, it must be the original length. Remember, after undergoing extension, it gains another length. The length will come from L0, for example, to L1. But whenever you are using here in calculation, you must use the original length. So strain is equal to extension over the original length. Now, the last one is just the ratio of the first two, which is Young's modulus. Young's modulus is just equal to stress over strain. But of course, you have seen strain is extension over length. This is length over length. It means that there are no units. We don't have units here. And then Young's modulus will be stress, which is newtons per meter squared, over strain, which has no units. So it means Young's modulus and stress have the same unit. That is newtons per meter squared. So I think we have moved so well with the three terms that are very important in the mechanical properties of matter or materials. So in summary, stress, force over area, tension, extension over length, original length, and then Young's modulus is now stress over strain. Units, newtons per meter squared, no unit, and this one is also newtons per meter squared. Having gone through this and seeing people smiling, we are supposed to challenge ourselves with an example. Now, this one is saying a mass of 1.5 kilograms. Remember, as in our solution, we can be summarizing what we have. Solution to the question. The mass is 1.5 kilograms. Here, we shall try to use the SI units. Is attached to a wire of length L is equal to 3.0 meters and produces an extension of E is equal to 0.60 millimeters, which we can change by dividing by 1,000 or multiplying by, okay, say over 1,000 meters. What else are we given? If the diameter of the wire, so diameter of the wire D is equal to 0.55 millimeters. Remember, this can be divided by 1,000 to get our diameter in meters. Because I've told you we must change to SI units. Having done that, you can now start approaching our question. Because this is just the summary of what we are given. So the first thing is get the cross-sectional area. In a few minutes we have been discussing, we said the cross-sectional area is circular. So it's simple, get area of a circle. So in our solution part A, area of a circle, yes, pi d squared, no. Yes, yeah, excellent. Pi r squared. Pi r squared, which is the same as pi, remember r is d over 2, so it's pi d squared over 4. So it's a matter of putting in our values and getting the answer. So this will give us 22 over 7 times the diameter, which is 0.55 times 10 to the power negative 3, which is divided by 1,000 over 4. Remember, this one is squared. This one is squared. So we can get our calculators and then we work out and see what that one will give us. I think your calculators are giving you values. Just put in substitute. We can use 22 over 7. Some people like using 3.14, but I know most of us in O level like using 22 over 7. So we work out this and we get our answer. And my calculator is giving me the area as 2.37 times 10 to the power negative 7 meters squared. Remember, this is a very small wire which has a diameter of 0.55 millimeters. That area is too small. But of course, we cannot say diameter of 10 centimeters. Remember, the wires we are dealing with are usually very small wires. So part B is asking us for tensile stress. So tensile stress, we have said, is equal to force over area. Now the force, of course, we are given the mass, 1.5 kilograms. For to change it to force, we just multiply by acceleration due to gravity. In this question here, we can take our G as equal to 10 meters per second squared. So it means that if we take it as 10 meters per second squared, then it means that our force will be mg over area. So our m is the mass, which is 1.5 times 10 over our area, which is 2.37 times 10 to the power negative 7. So if we work out this, we get our tensile stress. Remember, in Newton is per meter squared. If we check with our calculator, this is 1.5 divided by 2.37, and we are getting 6.33 times 10. Remember, this goes up and becomes positive power 7. Yeah, to power 7. Power 7 Newton is per meter squared. Remember, that is our stress. And then C, we are getting our tensile strain. So what is important is not the meaning. If you know the meaning, it's a matter of substitution. Tensile stress is force over area. Never make a mistake and substitute 1.5 the way it is. You must change it to force. And the force of mass is weight, which is actually mg. Remember that g is given at the beginning of the paper. For you who are going to be doing your papers of physics, be checking for the constants at the beginning. They're always given to us. So tensile strain, we said, is E over L. Now, if the units are the same, you can just leave and use them because they cancel. But for this case, the units are different, so you must put them in one unit. And if for that case, we may put all of them in what? In meters. So this will give us, we're supposed to work vertically downwards, but for convenience of this board, I've worked there. But you are advised to be working vertically downwards. So our extension is 0.60. We multiply by 10 to the power negative 3, changing to meters, over our length, which is actually 3. So members, we get 0.2 times 10 to the power negative 3. Yes, and this will give us 0.0002. Remember, it has no units. It has no units, so we just leave it like that. And that is tensile strain. Now, our last task is to get Young's modulus. And I think, remember, it's getting easier and easier because we are applying our knowledge of the definitions. Young's modulus, as we said, is stress over strain. So we are just going to divide this by this. And we are going to get what we call our Young's modulus. So in D, Young's modulus, remember, is equal to stress over strain. So students, you can substitute, get stress, which is this, and then we divide by strain. When we do that, we are going to get divided by 0.0002. So we can see that our answer is actually 3.16. Our answer is going to be, let me just quote it here. You also check with your calculator, but I'm getting 3.16 times 10 to power, this was power 7, and this power 3, so it's to power 10 newtons per meter squared. That is Young's modulus. Students, I think you have enjoyed this last bit of the session. I can see people are happy, but of course, everything has where it has to stop. But you can now summarize by going back through what we've just been doing. They asked us for cross-sectional area. Remember, I told you a wire is always having a circular cross-section. So we have to get area of a circle. We just got area of a circle, and our cross-sectional area is there. Being area is meters squared. Then tensile stress was force over area, and then area we already had, but the mass, we changed it to weight to make it a force, and we got our unit is Newton per meter squared. Tensile strain, E over L, and then we got it, then Young's modulus, which was stress over strain. My calculator gave me 3.16 times 10 to the power 10 newtons per meter per meter squared. Of course, some people would be saying, why have we used very funny values? These are the realistic values of wires. So students, remember, we can now go and have this. This is our assignment. Next time I come, I'll get the solution. Remember, some of you can post it on our numbers. We have a WhatsApp number. It's rolling down there. You can also call us in case you have a problem. And remember, Mr. Wodidi Moses, teacher of e-learning project on Google Day TV. So students, you have been a very good audience, and I think you will continue enjoying our lessons. Wash the hands, keep safe, so that we can continue with our lessons until and until. I remain Wadidi Moses, teacher of physics on Google Day TV, sponsored by management of Google Day and the e-learning teachers project. Thank you for listening to me.